Hello everyone, I'm Abigail Loya, and today I'm going to talk about the seven quality tools. Well, in today's highly competitive global market, quality is a critical factor that can make or break the company. Customers demand high quality products and service, and organizations must deliver to meet or exceed the expectation. Quality control is a systematic approach to ensuring that products or services are processed in a way that meets specified requirements. This process involves monitoring and controlling process to prevent defects and reduce variability. To achieve this, organization rely on the set of tools known as the basic tools of quality control, which are widely used in the industry for continuous improvement. The seven basic quality tools are simple yet powerful techniques that allow organizations to identify, um, analyze, and resolve quality-related issues. These tools are applicable to both manufacturing and service industry and are used by quality management teams to maintain and improve process performance. They are not used for especially in quality control, but are also accessible to all employees involved in involved in improving process. This document delves into the definition, development, and application of these tools, offering insights into how they can be integrated into any organization to enhance process control and product quality. Now definition of basic quality control tools. The seven basic quality control tools are designed to address various aspects of process control and problem solving. Here's a detailed look at each tool. First is cause and effect diagram, Ishikawa or fishbone diagram two, and a graphical tool used to explore positional causes of a specific problem or defect. The structure of the diagram resembles a fishbone, where each bone represents categories of causes, and the purpose is it helps teams identify in categories the causes of uses, providing a structured way to explore different factors that could contribute to a problem. An example in a production line, experiencing defects in finishing goods. The visual diagram can help point out causes related to equipment, materials, methods, or labor. Um, check sheet. mm, Check sheet. Well, it is structured prepared for collecting and analyzing data. Is used to record how often a certain event or defect occurred. And the purpose is check sheets to provide an easy way to get in real time data on process failure, defect or non-conformance occurrence, which can later be analyzed to identify patterns. Example, a quality control inspector can use a check sheet to track the number of defective items produced in each shift over a week. Other is control chart, a tool used to monitor process variation over time and distinguish between normal, common cause, and special cause variation. It displays process data against predetermined control limits. Uh, Control chart help monitor the stability and predictability of process, identifying any deviations that need to be addressed. Example, in a bottle plant, control chart can be used to monitor the field levels of bottles, ensuring that the field volume stays within acceptable limits. Histogram, a graphical representation of data distribution in the form of bars. It shows how often different values occur within a data set. Histogram makes it easy to visually parse and variation in data, such as the distribution of measurements or process outcomes. Example as Histogram can be used to display the distribution of product weights in a patch to see if they meet specified tolerance. Other is Pareto chart, a type of bar chart that prioritizes factors based on their impact. It follows the Pareto principle, 18 and 20 rule, which suggests that a small number of causes often account for the majority of problems. Pareto charts help focus improvement effort on the most critical use by identifying the primary causes of defects or failures. An example, if a company experiences a high number of customer complaints, a Pareto chart can be used to determine which use, delivery delays, product defects, etc., are responsible for the majority of complaints. Scar diagram, a graphical tool that plots two variables to identify any relationship or correlation between them. Scar diagram help in exploring potential cause and effect relationship between process variables and outcomes. An example is in a factory, a scar diagram could be used to analyze the relationship between machine temperature and the quality of finished products. Um, Other is flowchart, process map, um, a diagram that visually represents steps in a process. It outlines the flow of activities and decisions from start to finish. Flowcharts help in understanding, analyzing, and improving process by showing how work moves through the system and where inefficiencies might occur. A flowchart can be used to map the process of customer order fulfillment, identify bottlenecks and redundancies. Well, and well, now the development of quality control tools. The development of the seven basic quality control tools is deeply rooted in the evolution of quality management philosophies, particularly those introduced by pioneers like um, W. Edward Deming, Joseph Juran, and Karo Ishikawa. These tools were developed as a response to the need for systematic data-driven methods of controlling quality in manufacturing. Well, Deming emphasized the importance of statistical process control and the use of control charts to monitor variation in process. His work laid the foundation for modern quality management practice. Duran focused on quality planning, quality improvement, and quality control, ad- advocating the use of tools like the Pareto chart for problem prioritization. Ishikawa introduced the cause and effect diagram to simplify problem analysis and emphasize a team-based approach to quality improvement. These tools were initially developed for use in manufacturing but have since been adapted for use in various industries, industries including healthcare, finance, and service industries. Over the decades, the development of software and technological advancement has made this tool more accessible and easier to apply in real time, thus improving their effectiveness and accuracy in quality control. Well, now application of quality control tools. The application of the seven basic quality tools can be tailored to the specific needs for an organization. Each tool serves a unique purpose and can be applied at different stages of process control or problem solving. Below are examples of how these tools are applied in a practice. Well, cause and effect diagram used during brainstorming session to identify possible causes of a recurring issue in the production line. By categorizing test cause, teams can focus on investigating the most likely factor affecting quality. And check sheets utilized in manufacturing to track the frequency of machine malfunction or defects in the patch. This data provides insight into where problems might be occurring and how often. Other is, well, control chart apply in real-time process monitoring such as tracking the consistency of product emission during mass production. When data points fall outside control limit, it signals a potential problem requiring immediate attention. Histograms are used in customer service departments to assess the distribution of response times, helping to identify trends and areas where service quality can be improved. Pareto chart apply in quality improvement projects to prioritize defects or customer complaints by their frequency or impact, enabling organizations to focus their resources on solving the most critical uses. Square diagram utilize to test relationship between variables such as the correlation between employee training or in the number of product defects in the factory. Flow chart used in operation management to map out process like inventory replenishment, allowing teams to identify unnecessary steps or delays that are affecting overall efficiency. Now in conclusion, the same basic tools of quality control provide organization with a structured approach to identifying, analyzing, and solving quality-related issues. By applying these tools, um, companies can not only detect and correct problems but also prevent future defects, leading to continuous improvement in process. These tools are widely applicable across industry and can be tailored to fit the needs of any organization. Their simplicity makes them accessible to all employees, fostering a culture of quality awareness in collaboration with the organization. Um, In today's competitive environment, maintaining high standards of quality is essential for success. Integrating these tools into everyday operation allows organizations to stay ahead of the competition by ensuring that their processes are efficient, consistent, and capable of producing high-quality outputs. Whether in manufacturing, healthcare, or service industry, the same basic quality tools are invaluable in driving process improvement and ensuring customer certification. Well, is that is, and thanks for your attention. Bye bye.